Greetings, geometry students. This is the next to last set of notes in Unit 4 that will be going towards Monday's test, and today we are looking specifically at the structure of isosceles triangles. Please copy down the title, and the date for these notes will be Wednesday, December the 10th. Let's take a look at the objectives. Our stated objective for today is to learn special vocabulary and properties applying to isosceles triangles. Now, as you will find in geometry, plenty of times we have special vocabulary that only accompanies certain types of shapes, so make sure you pay attention to the fact that these terms are only for isosceles triangles. Okay, on your assignment, you're going to demonstrate the ability to apply special vocabulary and properties for isosceles triangles in order to solve for missing information. And your essential question for the day is, do I understand isosceles triangles? As always, press pause anytime you need more time to get something copied down. Do not let the video just pass you by, and then hit play when you're ready to move on. Okay, now isosceles triangles are of particular interest in geometry since they have so many of the properties that we have been talking about all in one figure. And even with the properties we have already discussed, plus the ones that we're going to look at today, we will still have only basically scratched the surface. There are tons of properties going along with isosceles triangles. Okay. Now, a little bit of basic review. Hopefully you remember this because it hasn't been too long into the past. The word isosceles is a term that we have defined before, and the word isosceles means it is a figure that has at least two sides congruent. Now, of course, it is possible to have more than two sides congruent, but we're looking at least two sides congruent. And of course, also keep in mind that the term does not apply only to triangles, although that is what we are looking at this unit. Okay, but it also applies to quadrilaterals, pentagons, any type of shape that we might run across can use the term isosceles. We just see it more often in triangles than any other shape. Now, before we look at the properties that all isosceles triangles carry, we are going to need some basic vocabulary because the properties do refer specifically to that vocabulary. And as I already said, isosceles triangles are something that carry their own vocabulary, kind of like their own little language. So we need to make sure we learn these terms and the way that these terms apply to isosceles triangles. Because some of these terms we have seen before, but we've seen them with slightly different definitions in slightly different shapes. Okay. Now, in an isosceles triangle, and what we're going to do is we're going to be using an isosceles triangle to add several items and structures into our triangle. So if you will draw this triangle large enough, and by large enough I mean maybe 5 or 6 lines tall in your notes, you will be able to just use this triangle over and over again with the several pieces of vocabulary that we have coming on the next few slides. Okay, so in an isosceles triangle, and there is an isosceles triangle, it is isosceles because it has at least two sides that are congruent. But for the purpose of this lesson, we're only going to focus on triangles that just have two sides congruent, but just remember the definition means at least two sides congruent. Okay, the two sides that are congruent to each other are called the legs of the triangle. Now, this is a fact that I had hinted at when we were going through some of our basic vocabulary with triangles. Okay, but now we're going to establish that in our notes. The two sides that are congruent to each other are referred to as the legs of the triangle. So in your triangle that you have already drawn out, please add the term leg besides where you have each of your tick marks. Okay. The side that is different or unique is called the base of the triangle. Again, the two sides that are congruent to each other are called the legs of the triangle. The side that is unique is called the base of the triangle. So in your diagram, please add the term base along with the one side that does not have the tick marks. Okay? Now, one little word of hazard here. Okay, we've already seen some things in geometry that can cause us some problems. Here is a major one that causes us problems. You will see the term base in geometry, okay, several times. However, the thing that you need to remember is that the word base in geometry does not mean what it sounds like it means in the English language. When we talk about a base in the English language, we think about something being on the bottom of something else, but in geometry it has nothing to do with being on the bottom of anything. Okay, so the diagram that we just looked at, and you might want to doodle this guy off to the side along with this note, that diagram could have just as easily been constructed like this as opposed to the way that it was. Okay, so if this was the diagram, okay, it makes absolutely no difference as to where the bases and the sides are. Okay, the two sides that are the same measurement are the legs of the triangle, and then one side that is unique is the base of the triangle. So please keep that one filed away for all year. Base does not mean bottom. Okay, let's move on. All right, in an isosceles triangle, this is what your current diagram should be looking like at this point. Now, where the two legs of the triangle join together is what we call the vertex of the triangle. Now, the word vertex is not an unusual word, or not an unfamiliar word. We have already been using the term vertex in this particular unit already. However, okay, this vertex is slightly different. Now, obviously, the location, okay, following along with the definition, is positioned right there. So please add that guy to your diagram. Okay, and he is called the vertex. Now here's where the geometry gets a little strange, because we run into some naming situations where some things get a little bit confusing. Okay, and this is a very unfortunate vocabulary occurrence, and it's going to require a little bit of attention by you guys to make sure that you get this information correct. As we have discussed before, the place where two sides of a polygon join together is called a vertex. Okay, this is still true. This definition does not override that the corner points on your triangle are they are a vertex and another vertex and another vertex. So there are three vertices that are in an isosceles triangle. However, the one vertex that is connecting the legs of your isosceles triangle is referred to as the vertex of the triangle. It's extremely unfortunate that they named it the way that they did, but this is what they've got. Why it was never changed, I really cannot say. Okay, but just be advised, if a question is asking you about how many vertices a particular polygon has, then you count up all of the corner points where the sides are joining together. If a problem refers to the vertex, then you better be looking for a unique location like where the two legs are joining together in your isosceles triangle. Okay. All right, so our diagram looks like this at this point. And where the vertex of the triangle is, an angle is formed by the two legs. This is called the vertex angle. Where the vertex of the triangle is, an angle is formed by the two legs. This is called the vertex angle. So please add to your diagram the vertex angle. No real other properties to go along with the vertex angle just yet, but we just need that piece of vocabulary. Okay. Okay, so our diagram should look like that. For some reason, my vertex angle has vanished from my diagram, but you should have it in your notes. Okay, so in an isosceles triangle, where a leg and a base join together, an angle is formed, and it is called a base angle. Where a leg and a base join together, an angle is formed called a base angle. Now there are two such angles in an isosceles triangle. And be sure to mark them in your picture. Okay, so the two angles that make contact with the base itself are referred to as base angles. All right. Let's look at a couple of examples so we can see how the math works here. And particularly what you're looking at there, you see in the diagram there are several variables that are missing information. This is part of the reason why test writers like to pick on things like isosceles triangles, because there are so many little properties running around inside of them. They can provide us with a limited amount of information, and then they can ask us a variety of different things about the problem. Okay, so the instructions on this are find the values for the missing variables. Now, when you have problems like this where you have to solve for multiple different variables, a lot of people's tendencies are to look at the problem alphabetically, meaning they will tend to try to solve for x before solving for y and try to solve for y before solving for z. I assure you this is not necessarily the best strategy. It's not a bad strategy. Just keep in mind that there may be situations in a problem where you cannot solve for one variable until a different variable has been discovered first. Okay, so it's not a bad idea if you want to walk through things alphabetically, but don't be afraid to leave a particular variable alone, especially if you get stuck. Go work on the other variables and then come back to the one you got stuck on and see if maybe you can't solve it after some of this new information about the other variables has come to light. Okay, so let's start off with the x. Okay, as you can see, x is attached to one of the legs of the isosceles triangle. And we well know by the tick marks and now our definition for legs that the legs will be congruent to each other. So since the legs of an isosceles triangle are congruent and we have one of the legs already marked as a 5, x of course must also be 5. Okay, so no big deal on that one. That's a problem we could have worked back in the first couple of weeks of school because we knew what the tick marks mean. Okay, now let's look at the angle measurements. Okay, one of the associations or the rules properties that we have used this unit is that the side lengths and the angle measurements are related to each other in a triangle. If you have a very large side length, then across from that side length you will have a very large angle. If you have a small angle, then across from that angle will be a small side length. But we said that also works if you have a tie. And in this case we do. We have two side lengths that are the same measurement. That means that the two angles across from those two side lengths will also be congruent. So if you have one angle measurement across from a tick mark that is 50 degrees, then what kind of an angle measurement are you going to have across from the other tick mark? It will also be 50 degrees. Okay, now on to z. Okay, we don't have a property looking at us in the diagram like we did with x and y to tell us what's going on with z. So it's time for us to kind of ask ourselves, what do we know about the picture? What can bring us information about z? Well, z is one of the interior angles of this triangle. And we know from this unit that the three interior angles on a triangle will add up to equal 180 degrees. So if we know two of the angles, then we can easily find the third angle. Well, we do know two angles. We know two of them are 50 degrees. So if we take the two 50s that we know and add them up with the z that we do not know, the result of that sum is 180. Okay, so walk through your 5 steps of solving an equation. Parents' complaints vary for everyone. The first step we will get to that we need to do is combining like terms. We have a 50 on the left and another 50 on the left. Those are both constants. There's no reason for them to be apart like that, so we will add them up. That's 100. And then we will find on the next step there is no reason for the 100 to be over there with our z. So we can subtract it to the other side of the problem, and z is 80 degrees. So as you can see, it takes a little bit of thinking, but none of these problems were particularly hard. Now, of course, the diagrams can get a little bit more complicated, the values can get a little bit more complex, but it's still the same properties, so it's still the same thoughts that you're going through as you go through these different variables. Okay, we have one more example. This example says find the values for the missing variables. Okay. And this one I would like you to try on your own. I'd like you to see if you can solve for x and y. Now, this problem, even though it looks different and the values are different, this uses exactly the same rules and exactly the same properties that the last example did. Okay, so when you look at this one, if you're going to come to class and say, well, I didn't get it, I expect you to have at least tried to make this problem look like the last example did, because it uses the same basic calculations. Okay, so copy this guy down, see if you can solve for x, see if you can solve for y. Please bring those solutions with you into class tomorrow. Jot down your summary. Okay, notate any questions that you may have that you need to come in for tutorials and ask, and always keep your essential question in mind. Do I understand isosceles triangles? I appreciate you finding time to get your notes taken care of. I will see you in class.